So in number 5, we want to solve some exponential equations. All right, so our rule for solving exponential equations, the first thing we want to look at is, can we get the bases to be the same? Because if I have two numbers where the base a to the power of x is equal to the same base a to the power of y, then I can just solve by setting my exponents equal to each other. So if I look at the first one, 4 to the power of 3 minus x is equal to 1. Can I rewrite these guys to have the same base? Yes, because this guy, this 1, I can rewrite 1 as 4 to the power of 0. Anything to the power of 0 is equal to 1. So this really becomes 4 to the 3 minus x is equal to 4 to the 0. And because my bases are the same, I can just take my exponents, set them equal to each other. And then to solve, I'm going to subtract the 3 from both sides, divide by the -1. I get x is equal to 3. Okay. Looking at number, it doesn't have a number. The next one, 8x to the power of x plus 2 is equal to 4 to the power of x minus 1. All right, so can I get these guys to be the same base? Yes, but I'm going to give you a hint. It's not a base that's currently present. Yeah, so 4 to what power will give me 8? There's nothing. 8 to what power will give me 4? There's nothing. But they're both powers of 2, right? 8 is just equal to 2 cubed. 4 is equal to 2 squared. So even though there's no 2 present as a base, that's fine. You can still rewrite them. This guy would become 2 cubed to the power of x plus 2, and the 4 becomes 2 squared to the power of x minus 1. All right, then when you have an exponent raised to an exponent, remember our rule is we can combine them by multiplying the exponents together. So this really becomes 2 to the power of 3x plus 6 is equal to 2 to the power of 2x minus 2. Same base, so we set them equal to each other. And now I am going to solve for x. So I'll subtract 2x from both sides. And that gives me x. I'm going to subtract the 6 from both sides. So I get x equal to a -8.